Alright, review for CFA3, Unit 2, linear and nonlinear functions. Problem number 1. The taxes of a room can be calculated using the function 0.63x plus 4.8, where x is the cost in dollars and t of x is the tax in dollars. Which notation shows the cost in dollars if taxes were paid? Alright, so when I approach this problem, I want you to remember that y is a function of x. We talked about that at the beginning of the unit. They tell us that y, which is right here, taxes is a function of x. So f of x, t of x is the taxes in dollars, x is the cost in dollars. So I created an xy table here, and I labeled that x is the cost in dollars, and I also labeled that y is the tax in dollars. Next, I'm going to go to Desmos, and I'm going to key in this function, and then we're going to open up the table of values so we can decide what's the correct inputs and outputs. On the table, this value is the x, and this value is the y, because this is f of x equals y. Alright, so let's come over to Desmos Graphing Calculator. See if I can find it. And we're going to enter the function y equals 0.63x plus 4.8. Alright, so here's the line. I'm going to press this little settings and get the table. And I have some values here. Okay, now look. These values are not what we need. Look, one of the first values we need is to find out what is y when x is 12. See right here, what is y when x is 12? Let's test that out. So we'll come here, and on this table, we'll put 12, and we get 12.36. We wanted 12.36. So A works. Alright, the next one is 5.52. What happens when x is 5.52? So we come here to the table. I'm going to type in 5.52, and I get 8.27. Looking at my choices, you'll see right here, 5.52 for x yields 8.27 for y. So that one works. I'll show you again. Let me slide this over. Okay. So we typed in the function at the top. We pressed the settings button, and then we went to the table of values. On the table, we needed to see when f of x is equal to this y. We typed in 12 into the table, we got 12.36. We typed in 5.2, we got 8.27. Now we're going to type in 0.63, and we get 5.20. This one will not work. This one will work. And then the last one I want to check is this one. Yep, that one works, because right here it says 6.63 is $5.20. So all of these will work except for C. F of x is equal to y. Y is a function of x. This value is your x value. This value is your y value. And you need to tell when they match up. Alright, question number 2 and question number 3, I'm going to put them together. This is called what type of function? And this is called, hold on, let me move my calculator. Alright, this is an absolute value function. You should be able to identify it as an absolute value function. This is, it looks like an E, doesn't it? Whee! Exponential function. Alright, now, both of these are non-linear. That means that they do not have a constant rate of change, and they do not make a straight line. So this is non-linear. Alright, and just for fun, this is the square root function. It is also nonlinear. This is the this is the cubic function. This is a cube root function. This is the square root function. And both are also nonlinear. Alright, I think that is all I needed to go over with you. Oh, no. Let's review one more thing. Do you all remember the last video I posted about the parent functions and what happens when you evaluate them? Let's say you have a quadratic and you want to compare this quadratic to g of x equals negative x squared plus 2. This is the parent, and you should know that the parent function is written as y equals x squared for a quadratic. Had it been an absolute value, I'd expect you to know, okay, this is an absolute value function, and the parent for an absolute value function is y equals the absolute value of x. Okay, now what do we do with that information? We got to compare them to see what is true at, let's say, f of negative 1 and g of negative 1 for both functions. Is it greater than, less than, or equal to? And then the same thing for this one. This parent compared to g of x equals the absolute value of x plus 2 on the inside of the absolute value bars. And we're going to compare this one at negative 1 as well. Greater than, less than, or equal to. And we, like I'm just choosing these numbers, this negative 1. We can evaluate f of 0. The important thing is that we know how to evaluate it. Alright, so we're going to come over here to our graphing calculator again. And we're going to type in the parent function for the quadratic. Y equals x squared. And then we're going to type in the second function. I don't want to close it out. The second function is y equals negative x squared plus 2. Y equals negative x squared plus 2. Okay, so now we have both functions. They are actually the same value at negative 1, and they are the same value at 1. That's interesting. Alright, come to the tables. Get this table as well. And let's make some comparisons. Alright, so at negative 1, the first value is 1. So over here on my paper, I'm going to put negative 1 is 1 for the first one as an ordered pair. On the second one, at negative 1, we get 1 also. See right there, 1 for this function. So this one is also negative 1, 1. So I wrote these are the same values. Therefore, they are equal at negative 1. Alright, the next one. We're going to do the absolute value of x compared to the absolute value of x plus 2. Alright, so I'm coming over to the calculator. Y'all go ahead and type those in. Y equals the absolute value of x, and y equals the absolute value of x plus 2. Alright, we're going to pull the table for both of them. And we're going to compare them. I don't see the table for this one. There we go. There's the table for that one, and there's the table. The values that we're comparing is at, let's do negative 1 again. Alright, so we come over here to the table. Bloop. We find the values at negative 1. This one is at 1. See right here? Negative 1 and 1. This one's at 1. So I'm going to write on my paper negative 1, 1 for the parent. And then the other one is absolute value of x plus 2. The absolute value of x plus 2 at negative 1 is also 1. Negative 1, 1. They're the same again. Oh, they are. They both overlapping right there at that same point. So again, they're equal. When are they not equal? At positive 1, the black one is lower than the parent is at a lower value than the child. At 2, the parent is at a lower value than the child. At 2, the child is at 4, and at 2, the parent is at 2. So the child has a higher value. That was fun. Alright, if you have any questions, ask before we take this CFA. Otherwise, happy assessing.